Alright, roll. Number one, we have the area of a square with the side length of 2x plus 3. You can tell me what we need to do.
Multiply 2x plus 3 times
Okay.
12.
Yep, so the area is 2x plus 3 times 2x plus 3, so yes, you're correct, the box method. Alright, so if we box it, we should get 4x squared plus 12x plus 9 units squared, so it's area. 4x squared plus 12x plus 9. It's fine.
9. Oh, 3 times 3 is 9.
It is. We put 6.
Yes. I always do that.
It's also how a teacher can figure out what's coming. Alright, 288. So we're simplifying the square root of 288. Alright, so this is what we worked on last week before the 3-day break. What we need to do?
Bring what, put square root of 144 in the square root of 2. Oh,
Why 144?
because 144 is the largest number that goes in.
Okay, perfect. We want a number off this list that's the largest that goes into it. So Lily said it's square root of 144 and the square root of 2. And the square root of 144 is 12. Bring down that square root of 2. There's your answer. Alright, who's got number 3? Lunch, what do you got?
No, I just
Oh.
got something different on 2. But
Okay.
I did do number 3 too.
Okay,
Okay.
let's fixture number 2.
Okay.
What'd you do?
I didn't do 144. I got 36 and 8.
Okay? Because that does work. 36 times 8 is 288, right? Okay, carry 4. Yeah. Okay. What's square root of this?
6.
6. Bring down my square root of 8. What's the ish?
What do you mean?
Is that as small as it can go? Did I say it here last week or did I say in 5th period last week that I'd almost bet my life savings that somebody would do it? Must have been 5th period. This isn't simplified all the way. Because 8 still has a number on this list that goes into it.
Oh.
Okay? So this can break down
Oh, okay.
the 4 and 2. That's 6 times 2 times the square root of 2, which is 12. 12 square root of 2.
Okay.
Okay. Make sure we're simplifying this all the way. All right, number 3. What number are we going to use from over there? 25 and 3. So that becomes 5 square root of 3. Alright. And number 4, what's different about number 4 than 2 and 3?
It has the 9 on the outside, so you have to multiply.
Has a 9 on the outside, so it's a coefficient in a sense, right? So we're not going to do anything with that, we're just going to break it down. And what is this 300 going to go to?
103.
103. So it's 9 times square root of 100 is 10 times square root of 3, and 9 times 10, 90 square root of 3. There's my answer. Okay. So we were working on problems like 2, 3, and 4, I guess Thursday and Friday. I guess more Friday, right? Because Thursday we finished up math testing,
I know.
so really just Friday. We're gonna zoom past this a little bit. Did you watch Team Umizoomi?
Yes.
David Bowman's laughing, so he must watch it. So Umizoomi, they zoom. Anyway, so we're still gonna touch on these things, but we're gonna add an operation to it. But we'll get there in just a second. All right, so 5, 6, 7, 8, 9. We have to figure out whether it's rational or irrational. So number 5, rational or irrational? Why is it rational?
Because the square root of 25 is 5.
Very good.
5 is
Number 6, rational, irrational. It is rational. Number 7, rational, irrational. Why is it rational?
because it repeats.
Repeats. That bar right there means it repeats, so it's rational. Number 8,
I don't know.
or irrational?
Irrational.
Irrational?
Why? Yeah, why?
Because the square root of 9 is 81.
Okay.
So you can't like square root it.
Right, so we have the square root of 81, which is after it. We have the square root of, what, 64, which is before it. These two are perfect squares, so these two are rational. 72 is between those two, so therefore it's irrational. Because if I plug my calculator, square root of 72 is going to give me a decimal that does not repeat, does not have a pattern. And number 9,
Irrational.
irrational. There's no pattern, dot, dot, dot means it continues forever,
Okay.
so it's irrational.
Can I ask you a question?
You just did?
288, so that would be irrational, right? Like that, but the number 2 would be
Yes.
irrational. Okay, okay,
So all three of these are technically irrational.
okay.
Right. The only ones that would be rational are any of these square rooted. Okay. Alright, so that is a little overview of polynomials, simplifying radicals, and rational and irrational. Just a little bit of things that we've touched on. We're going to go a step further with our radicals today, and we're going to throw in some operations. Alright, so today we're going to throw in our adding and subtracting operations. And hopefully it's not too confusing. And hopefully we're getting a grasp of this, because that will definitely come into play. Alright, so if you need a piece of paper, if you want to take good notes, or if you just want to add it to your bell ringer, that's fine. I will never take up your notes, so you can put them wherever you like. Alright, so today we're going to work with adding and subtracting, that's why I'm a math teacher, radicals. I can't spell. I used to be able to spell. Like when I was in 3rd grade and, spelling words. Words got bigger and longer and more confusing. Simplifying radicals and adding and subtracting them. When adding and subtracting radicals, we want to think of back to like terms, right? And what does it mean like terms? How do I add and subtract like terms? What do I have to have?
The same
Same base variable,
term.
yes. Same base or variable with the same exponent. Okay, so in order to add or subtract like terms, we had to have that same base or same variable. Kind of the same concept with radicals, but we've noticed so far that in radicals we don't have variables. At least I haven't shown you any yet. We're going to, but we haven't shown you any yet. So we have to figure out what makes radicals same or like terms. All right, so here's example number 1. We're going to have 3 square roots full 5, because 4 is a perfect square. I can't put 4. I mean, I guess I could, but I'm not going to. Plus 2 square root 5. When looking at these, they look like terms. Julie said yes. Do they look like terms? Is there anything similar about them?
So that has a square root of 5, but the coefficient of 3 and 2 are different.
Okay.
So can we?
So let me ask you this. If I had 3x plus 2x, can I add those?
Yes.
Because x is the same, right? And 3 plus 2 is 5, so it's 5x. When adding and subtracting radicals, that's what I'm looking for. I'm looking for the radical, or really the radican, right, the number inside. And if that number is the same, I can just add the coefficient. So in this one, I can just take 3 and 2, add it together, just like I did over there in my variable, and get my answer. So 3 plus 2 is 5, and I bring down my square root of 5. There's my answer. Doesn't seem too difficult, right?
So you don't have to simplify it?
Well, I can't simplify it because 5 doesn't have a number from this list that goes into it.
Okay, well, if you did have to simplify it, do you have to, like,
I'll get there.
okay.
Yes. But yes, we will have to get there. Questions on that? Not too bad. Example 2. Let's do 6 square root 7 minus 2 square root 7. Do I have quote unquote like terms? Yep, they're both square root 7. So I can just add those, or sorry, subtract 6 minus 2. We got 4 square root 7. Mr. Fortune can't be this easy, can it? Yes and no. These are the easy examples because I progressively get harder. Okay. Some questions on those two. I would ask people on the camera, but they're not live, so they'll have to email me the questions later. All right, so let's get into what Madison was talking about. What if? All right, so example 3. Let's see if I already have a good example over here that I can do. Yep. Square root 18 plus square root of 50. And if you notice, the radicands are not the same, so I can't add them, just like I can't add x plus y, right? I can't combine them. But what do I notice about 18?
Yeah.
It can be simplified. What do I notice about 50? It can also be simplified. So I'm going to simplify them and then see if I can put them together. Alright, so 18. Alright, that's going to go to square root of 9 times the square root of 2, which becomes 3 square root of 2. Now I'm going to do the same thing with 50. I'm going to simplify 50. Alright, so 50 we're going to use 25. So that's going to be square root of 25 times the square root of 2. And the square root of 25 is 5. Bring down my square root of 2. Now that I've simplified both those numbers, what do I notice?
Like terms.
They are like terms. I can add them. So 3 plus 5, 8 square root of 2. And there's my answer.
Is that the hardest set of bits?
I mean, you might have 3 terms instead of just 2. Okay. But here's what I'm going to throw out at you in case we have a brain fart and we forget how to do it, or whatever the case might be. You know, the next couple days I'll try to get you all calculators. If I type this into my calculator just the way it is, it's going to give me a number, a decimal, probably 9 point something, right? And then if I take my 4 answers or 5 answers, depending on if I'm doing a POC or a milestone or whatever, if I plug this in the calculator, that number as a decimal should match this number, right? Do you agree with that? Okay. The only thing I would make sure to pay attention to is that this is completely simplified, because there might be a wrong answer that this isn't put in. So, for instance, we could see for square root 8, that would also give you that, right? But this is not simplified all the way, so this would be a wrong answer. Okay. Does everybody understand what I mean by plugging in the calculator? Okay. All right. Example 3, let's do example 4. If I can find a harder one here. Since y'all are grasping this pretty quick. Let's do 6 square root 28 plus 8 square root 10 minus 3 square root 7. Oh yeah. What's the problem?
They're not like terms.
Okay, none of them are like terms. Just hit puberty again. None of them are like terms because I got a square root of 28, square root of 10, square root of 7. Okay. So I can't combine them. So what am I gonna look at next?
Simplify all of them and then see if you have like terms.
Okay, so I'm gonna see if I can simplify any of them. So 28, can that be simplified?
Yes.
Yeah? How?
4 and 7.
4 to 7, okay. I'm gonna bring down this 6 times square root of 4 times the square root of 7. So that's gonna be 6 times 2 times the square root of 7, which becomes 12 square root of 7. Okay, so that one's simplified. 8 square root of 10. Can that be simplified? No, because the only two numbers I can work with are 9 and 4. 9 doesn't go into it, 4 doesn't go into it. So I can't simplify that one. So I want to bring it down. Three square root of 7?
No.
No, 7's prime, because 4 doesn't go into it. So I'm just going to bring that down. Minus 3 square root of 7. Based on those three terms, do I have any like terms? 12 square root of 7 and 3 square root of 7. So I can do 12 minus 3, 9 square root of 7. Alright, what about that 8 square root of 10? Just bring it down. And there's my answer. And that's about as tough as it gets. Until we get into multiplying. I think it's.
Is multiplying hard?
No, it's not.
Is it all doing today?
Excuse me?
Is that all we're doing?
That is probably all we're gonna do today. We might get into multiplying a little bit. Or I just go ahead and give you examples of multiplying and then we can work on adding and multiplying today and tomorrow. You wanna go ahead and give you examples of multiplying?
Yeah.
Since this is kinda easy?
Yeah.
Yes.
Or do you wanna work on some of these, then come back to multiplying?
Honestly,
No, multiplying.
Just go ahead and do multiplying.
It's gonna be easy.
Alright. Alright, so we'll just move on, give you some examples of multiplying. Alright, so draw your little squiggly line on your notes if you want. Alright. Let's do some multiplying. And multiplying, if we think about how we simplify the radicals, we're kind of working backwards with this. We will not divide. We will not divide, but I might show you how to do it anyway. I don't think we have to know it for the EOC, but I might go ahead and just show it to you anyway, because it's fun. Why not? It's math. So multiplying radicals. When multiplying radicals, so just like anything, we can multiply anything together we want, right? So think about variables. We can't add x plus y, but we can multiply x times y, right? So same thing with radicals. We just learned that we have to have like radicands in order to add them, but when multiplying, that don't matter. You can throw that out the window, okay? Because we can multiply anything together. And here's what I mean by that. Let's say we have the square root of 5 times the square root of we'll just do 8. And if we think about back when we simplified radicals, remember when we had to split it down too? We had to find one from that list and then find another one. So let's say if we had square root of 200, we just had to break that down to 102. Because 100 times 2 gives me 200. So how do you think I would multiply these guys together, or girls?
You could simplify 8 into the square root of 4 and 2. And
I
then-
could, but I'm not gonna do that yet.
I don't know.
Just multiply.
Huh?
Just multiply 5 times 8.
Exactly. Right? So just like here, right? I factored 102 because 100 times 2 gives me 200. Well, if I can multiply 100 times 2 there to get 200, why can't I multiply 5 times 8 here? Right? And get square root of 40.
Oh, like you can multiply not like terms together if
Oh,
you're like
absolutely.
distributing.
So like I can't add x plus y, but I can multiply x times y and get x y.
So then we just simplify
So
40.
same thing. And now we're gonna simplify the 40,
Okay.
okay? So we're gonna find a number from this list that goes into 40, which is 4. We're gonna break that down. Square root of 4, square root of 10, which gives me 2 square root of 10. Now, we could have simplified this first, like Lou was talking about. We simplified 8. And that would have gave us 2 square root of 2. Right, because this would have been 2 square root of 2. And at this point, I didn't want us to do that first because it might get got confusing. I could just multiply that 2 times 5, give me 10, and just bring that down that 2. Right, because really my coefficient with this 5 is a 1. So 2 times 1 is 2, 2 times 5 is 10. Alright? So no. Example 2. Let's go. Um, 7 square root 6 times 3 square root 10.
Do we need to
Okay.
simplify? No.
Which multiply both.
So think about what we would do here.
Oh, okay.
How would this work?
You would just multiply 4 times 0 to be 12 and then x.
So I multiply 3 times 4, so it's my coefficients,
So it'd be 12x.
which is 12,
So you
bring down
just
that xy.
Multiply, so it'd be 21.
So same thing here, I'm gonna multiply the coefficients,
So 21
So
squared is
21 square root 6.
21, and then 6 times 10, 60.
And then we have
And now we're gonna see if we can simplify that 60 any by finding a perfect square factor, if there is one. So I'll start here, does 49 go into 60?
no,
No, it's 36.
no,
No.
no,
No. Yeah.
4 times 15.
Yes.
Yes. Does
So
it?
4. Huh?
Does 9 not go?
Yeah, I thought mine did.
9 times 7 is 63.
Yeah.
And 9 times 6 is 54. Alright, so this becomes 4 and 15. Alright, bring down this 21, don't forget about it, 21. Alright, so it's gonna be 21 times 2 times the square root of 15. Which would give me 42 square root of 15. How was that one? Got a little trickier. Now, let's get into the trickiest one of them all. Because now we're going to have to call upon things we've learned in the past. Which I guess really technically all these we have. So, example tree. Oh, let's see here. There it is. Oh yeah, this will be good right here. Square root 2 plus 4 square root 3 times square root 2 plus square root 3.
This looks fun.
It is fun.
Wait, but they have like time.
It is fun.
Oh, yeah.
What do I notice about what you have there?
They have
The
like
binomial
numbers.
times the binomial.
What do you mean by that?
Like
There's
there's
two,
times
yeah.
in each set of parentheses.
And haven't we done that before? Binomial times a binomial?
Yes.
Yeah.
And there also is like terms, so it's.
Yeah, there is like terms.
So you would just follow the regular rules, but do binomial times binomial. Oh.
Couldn't you just?
Because when we multiply the binomial times the binomial, then we do box method?
Yes.
Alright, so we're gonna do box method. So square root of 2 plus 4 square root of 3, yes ma'am.
Couldn't you just like add the 4, like the 4 and the 3, and then the other 3, and then those 2, and then you don't have to do it?
What do
You
you,
know what I mean? I think you could do that
why?
because it's just like terms, and you can add like terms. I think
What's
it's like
different about this problem?
they're in parentheses.
It, yes, and what separates the parentheses?
A parenthesis.
Right. If it were this, then yes, you do exactly what you said. This is multiplication, not addition.
Oh,
Okay.
So then we
Alright,
got.
so we got 2, so square root of 2, 4 square root of 3 there, and we have square root of 2 here, square root of 3 here. Okay. Now we're going to take the rules that we've just learned, along with things we've done in the past, to complete this box. Alright, so we got square root of 2 times the square root of 2,
Square root of 4.
which is the square root of 4. Okay, we'll go back and do things to it in a second. Square root of 2 times 4 square root of 3.
What's square root of 6?
4 square root of 6, right? The 3 and the 2 are inside the radicand, so we're gonna multiply those two numbers to get it inside the radicand. Very good. Square root of 3 times square root of 2,
Square root of 6.
square root of 6. And square root of 3 times 4 square root of 3,
4 square root of 9.
4 square root of 9. So now, once I have all those numbers inside my box there, I can simplify radicals if I can, and combine like terms if I can. So square root of 4, does that simplify?
Yeah, the 2.
Yes. Let's do this. Let's color code it for those on TV. Live stream TV, right? Alright. So what about square root of 6 and 4 square root of 6?
That is 5 square root of 6.
5 square root of 6. And it's black, since I don't have no black up here. 4 square root of 3.
12.
How'd you get 12?
Because the square root of 3 is, the square root of 9 is 3, and then you multiply 4 times 3, which is 12.
Very good. So this right here becomes 12. Now let's look at what I got there. So anything there I can combine.
So how did you get 12?
12, so 4.
Square root of 9 is 3. 4 times 3 is 12.
So it'd be 14 plus
So my final answer, yep, so 2 plus 12 is 14,
14 plus 5 square root of 6.
plus 5 square root of 6. And that's probably about as far as we'll get as far as multiplying goes. Something like that, binomial times binomial. Questions? We just covered addition, subtraction, and multiplication. Hey y'all! Maybe since we went over it super quick, we'll go over division one day, not today. Alright, from there, we're going to draw just project problems. Let me stop my video real quick.